Hello, everyone, and welcome to Grinds Online Ireland. I'm Tara, and today we're going to be focusing on complex numbers. So, today our question is going to be solve the equation z over z plus 1 is equal to 1 plus 2i. So, because the left hand side must be equal to the right hand side, it's clear here that z must be a complex number. And the trick with these equations, guys, whenever we're asked to solve a complex number equation, we always call z a plus bi. And now our question is going to be a different question now. Rather than finding z, our job is to find a and b. So what I'm going to do is I'm just going to substitute in a plus bi wherever I see z. But before I do that, maths is all about getting rid of what we don't like in the equations. What don't we like here? We don't like that fraction. So how about I multiply both sides by z plus 1 and I'll be left with z is equal to 1 plus 2i multiplied by z plus 1. Multiplying that out then, what we'll get is z plus 1 plus 2iz plus 1. So we'll have z plus 1 plus 2iz plus 2i. Okay, so let's kind of put all the reals together and all the imaginaries together. So now our new equation, on the left-hand side, we're still left with z. And on the right-hand side, we're going to be left with the z plus 1 here. And then the imaginary parts, we can factor out 2i, and we're just going to be left with 1 plus z. Okay, next stop now is to plug in a plus bi. So if I do that, I'm going to get on the left-hand side a plus bi. And on the right-hand side then, we have a z, so I'm going to substitute in a plus bi plus 1. And then plus 2i, 1 plus a plus ib. So all I did there was substitute wherever I see a z, I'm going to put in the a plus ib. Okay, so now how about if we multiply this out? So on the left-hand side, we're still going to have a plus bi. And on the right-hand side, I'm going to have a plus bi plus 1. So then we'll have plus 2i plus 2ia plus, and we have to be careful here, 2i squared b. But guys, if you remember now back to the very start of complex numbers, we know what I squared is equal to, don't we? It's equal to minus 1. So we can go ahead and substitute that in. So we're going to be left with, instead of here, what we'll be left with is minus 2b. Okay, so how about if we group all the reals together and group all the imaginaries together now on the right-hand side, because that's basically what complex numbers is in a nutshell, grouping all reals with reals and all imaginaries with imaginaries. So all the real numbers are the numbers that don't have an I with them, so that's just going to be a from here, plus 1 from here, minus 2b from here. Okay, and that looks like all of them. So that's all our real numbers. All our imaginary numbers then, well, we're going to have the I in front, and then we'll have the bi. So the b plus 2 from here, plus 2a. Perfect. So guys, whenever we have two complex numbers equal to each other here, like we do in this case, we have a real part on one side and a real part on the other, an imaginary part on one side and an imaginary part on the other. What we can do is we can instead form two equations where the real is equal to the real and the imaginary is equal to the imaginary. So if I look at the real part on the left, that's just going to be equal to a. And the real part on the right then, that's just going to be equal to a plus 1 minus 2b. If I look at the imaginary part on the left, that's just equal to b. And if I look at the imaginary part on the right, that's just equal to b plus 2 plus 2a. So all I did in this case, guys, was I said, okay, the real on one side is equal to the real on the other, and the imaginary part on the one side is equal to the imaginary part of the other. And if we look at these equations, we can solve them. So let's focus on the first one here. Well, I can bring the a over and it becomes minus a. So on the left-hand side then, we're just going to be left with a minus a, which is 0. And over here then, we're still left with the 1 minus 2b. My next step could be, okay, I could bring the 2b over, so the minus 2b over, so it will become a plus 2b is equal to 1. And then finally, dividing both sides by 2, what we'll get is b is equal to a half. I can do the exact same thing here now with my second equation. I can bring over the b. It becomes a minus b, so I'll have b minus b, which is equal to 0. And that's going to equal to the 2 plus 2a. I can bring over the 2a now, so it'll become a minus 2a, and that'll be equal to 2. And then dividing both sides by minus 2, what I'll get is a is equal to minus 1. So as usual now, guys, with every exam question, this is an exam technique now I want you to get into the practice. So whenever you think you finished a question, you go back up to the question to double check if you answered it. So it was our job to solve that equation. So that meant find z. But we didn't find z, did we? We found a and b. So we're going to have to write then z, which was equal to a plus ib. What we're going to do now is we're going to substitute in a and substitute in b. So we know a in this case we found to be minus 1, and b in this case was equal to a half. So the complex number then that's true for this equation will be z is equal to minus 1 plus I multiplied by a half. Okay, I hope that was helpful for you, and thank you for watching.